Well, howdy, once again, physics sleuths and inquisitive souls, and welcome again to yet another lecture of dynamic gravity. So, today is conclusion day for years of my efforts and work on trying to generate some sort of gravitational or anti-gravitational force unnaturally that doesn't involve simple mass. And if you go back in my channel, I think you'll find the very first experiment I did on this was years ago, like probably 3 years now, maybe 4. And I really haven't had too much from these experiments to share that I can say is this or that. Just some hints here and there that there might be something going on. Well, today we're gonna break down my fourth and what is probably going to be my final experiment on a gravnetic field, generating an artificial gravnetic field, which is gravity, if you want to know the specific, the technical term for it, gravnetic field. Well, I guess it's not entirely true. Gravnetic field is when a gravitational charge is accelerating, but that's the one we want to create because that's the one that can be created that's not just from mass, and that's the one that can be a lot more powerful. Think like electric field versus magnetic field. You can get a magnetic field very powerful very easily using our tricks and techniques that we have with electronics, like electrons spinning in the same motion around conductors and blah 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 blah. If we could just do the same thing for protonic energy, then we would have access to gravity. So that's what I've been trying to do, and I don't even know what the results are yet. I kind of got a clue, but I don't know. I haven't done the math, and we are going to do some math today to confirm, yay or nay, whether or not I was successful or not. So that's going to be a thing, and this is probably going to be a longer video, but I'm guessing at this point. I really don't know. But there's something I wanted to show you. A couple weeks ago, I was out on my walkabout, and I saw yet another, moon with moon glow, or moon fire, whatever you want to call it. A phenomenon that I first saw going on for the first time about 10 years ago now. And since then, and I never saw it before that my whole life, and then since then, especially in the last few years, I've seen it a lot more. But it's just wild. And it's just, when you look at the moon, it just looks like it's on fire. Like with this glowy fire just enveloping it, right? And I try to capture this on cameras, but it's really hard because you got to have a really good camera. It's got to have just all the right lux settings and all the different, shutter settings and everything to really capture a nighttime photograph with the exact perfect clarity, I guess, that you want to get. All right? And I have failed this miserably. As you can see, this is the best I got. But what I want you to notice is I did succeed in proving that moon glow is a thing, and that's why I wanted to show you this, okay? Like, you see this? This is the moon right here. This is the upper part of the moon. And if we keep tracing this, you'll see that it definitely makes a circle that falls well within this glowy part, which is where all the moon glow is. All right. Now, the moon glow is most evident on the bottom, right here, on the edges, the side of the moon facing the Earth. All right. And I suspect that has something to do with the moonlight being tricked out by the Earth's atmosphere during aurora borealis events, solar storms, when there's a lot of charged activity in the atmosphere, and there's a lot of things that are happening, plasmas being made and whatnot. They're acting as lenses or this for any light being came through that. That's what I believe is going on. But I don't know, because I can't really measure it, and I can't find any person on the whole fucking planet that's ever seen this. And I can't find any reference on the entire interwebs about anyone talking about seeing this. As far as I know, I'm truly cray-cray and schizo right now, and that when I look at the moon, I see it on fire, and as far as I know, no one else does. But I just want you to know, I did capture proof that it exists, because you can clearly see, it looks almost like a yin-yang symbol, kind of, right? But you can see that this bottom half of the moon that's lit up, that's emanating light, is way, well, not way, but definitely larger than the circular circumference of the moon if we draw a circle here, okay? If we overlay a circle, there's definitely going to be part of this that is not going to be in this circle that's going to be glowing, emanating light, which is what I'm claiming, that there's this light that looks like an illusion of the moon is on fire, but I know it's not really on fire, but it looks like it. It looks like it's on fire, man. It's crazy. And there's another picture I got of this that you might argue is even better than that one. I have to do this the hard way, because it's always got to be the hard way. Okay. Now here's another one that I got. Wait. I can't get him a little more. There we go. Alright. Now this one, it was glowing a lot, and I was able to catch it in a really dark part of the sky where I had blocked out. Like, I don't know if you can see, but this is a roof that was, dark. And so I purposely got the moon just above the roof to blot out all the light, and I got like trees and everything blotting out all the lights. They're hitting me from street lights and everything around me. So it was just the moonlight and starlight that was in this picture, theoretically. And as you can see, here's the moon, and if we make the circle, if we complete this circle, the moon glow is way larger than this circle, okay? This confirms what I'm saying. It's not the exact picture as the way it looked as my eyes saw it, okay? But this shows you I'm not crazy. There is definitely a large amount of light that is glowing around the moon for some reason that is much larger, drastically larger than the moon itself. I mean, on some crazy nights of moon glow that I've looked up, the moon glow is almost taking up as much space in the sky as the moon itself. So I just want you to know that I'm not crazy, okay? I was able to capture some better evidence of this that I first put forth, in a video probably, a month ago? Not that long ago, really. And this is what I've got. And I'm telling you, with all the solar storms and the aurora borealis events going on right now, if you go out and look up at the moon every night, I believe you're going to see this effect sooner or later. It's going to happen. I mean, maybe if you're like on the equator status, maybe not quite so much, but especially further north, I think it is. 100%, I think so. So, yeah, moon glow or moon fire. I haven't decided what to call it yet, but definitely a thing, as you can see. And this night was one of the bigger nights of moon glow, as you can see. I mean, like, as you can see, the circle of the moon just right here immediately it bounces out like it's being held up by a cup of light, I mean, I wish I could have it crystal clarity as I saw with my eyes, but I just don't have the camera equipment and the know-how with the equipment I got to make it happen. And got to juggle a whole lot of things in case you ain't noticed, so it is what it is. Well, that's what you know. Your boy ain't crazy. I mean, I'm cray-cray, but I ain't crazy. Alright, there's a difference. One's cool and fun. The other is just weird, creepy. All right, but now that we got that out of the way, let us begin on what we got going on here. Okay. Let me see here. Guess I will begin showing you this. Okay, so this is my apparatus that I've been using to try and generate a gravitational thing. I know this picture is dark and garbage. Don't worry, you're gonna have a much better look at it here in a second. I just wanted you to be, aware that it exists. It's a thing. Okay. No, that's not it. Yeah, there we go. Okay. So, this is the device that I've settled on to try and generate gravity, okay? I think Tesla invented it or something. It's always Tesla, man. Tesla, bro. He's the real OG genius in our species, not Einstein, okay? Einstein created a mathematical construct that integrated time dilation into gravity, of Newton's gravitational theories. And it's great for that, but it doesn't account for anything else because it's only half the equation. I finished the other half of the equation. It's all there. It's all done on my website, or whatever, not website, but on my YouTube channel. Just look in the description. Every video I have a link to all my papers and everything, if you care. But the beauty of this is what it does. It just has a high voltage, ionizing air, creating plasma with a magnet and a copper coil here around there just to get better flow. And then it's going to create a spark, right? And this spark, because of the magnetic field, is going to get pushed a certain direction, all right? Like if we look, that's not it. Yeah, this one right here is a good video. This guy's got this mug, I guess, that's filled with, some gas like hydrogen or neon, some noble gas, right? It's airtight, it's filled, and he's got it on a power supply that's going to light it up, right? With electromagnetic energy, electric field. And so you got the plasma there, and he's going to put you can see as he puts the magnet on the plasma, it's going to make the plasma move. But as he sticks it in there, you see it's going to make it always go this direction, okay, like the right-hand rule, because that's the force that the magnet's pitting on the plasma, which is reacting to the magnet, okay, like that. So whenever you have plasma in a confined circle like that, and you have a very strong magnet in the middle of it, it naturally wants to move around in a circle. And this is what I want as someone seeking gravity. I want to get something that is as positively charged, like protons, as possible to be moving as quickly as possible in a very tight, small area, okay? This is how I believe we can create a gravnetic field. It's not easy, but I think it is possible, okay? So, that is what's going on there, okay? See it spinning? Bloop, 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 bloop. And he takes it out, stops spinning. So it's just, that's what plasma does, okay? So that's what's going on here. You got a spark that's generating plasma in our atmosphere with our gases, nitrogen mainly, and this always got little batteries touching to it. That's weird. But and then you got this magnet, which is forcing it to spin around very, very fast. Okay, like bloop 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 bloop. See it spin? And that's pretty fast too. I mean, if you look at the RPMs, I don't know what RPMs that is, but that's got to be fast. That's probably like at least like 100 RPMs a second, maybe 1,000. Who knows? It could get very fast depending on your composition of air and the plasma you're using that's being affected and your magnetic field that's propelling it. All right? But if we want to generate something like gravity, as we can generate a magnetic field from magnets, like an electromagnet, right? So we're trying to emulate here, only gravity with electromagnet. There's something you have to realize. This is spinning very fast, okay? But it is still not spinning as fast as a magnet is. Okay, look how fast this is spinning, because it's a very powerful magnet, all right? If you look in slow motion, he's going to do it in slow motion here in a second, and we're going to take a gander of what's going on under the hood, okay? See all the spots where the thing touches and establishes a conductive connection that transfers electricity from here to there. All these dots is a point where it's hitting, okay? And if we look, here we go. So we got, here's our spark made of plasma, right? Ionized air. And it is being forced from the right-hand rule around here. Now, there's two ways to interpret this motion. One of them is not any good to me, and the other is exactly what I want. But because of this picture, I think it is the one that I want. And let me demonstrate that for you, okay? I don't remember what this was. I was so lit. Who knows what day that was? That was crazy, though. Okay. So, let's say we've got our apparatus, right? Beep, beep, bop, bop, boop. And it's got our little thing right here. Okay? We got two. One works the way we want it to work. One works the way it doesn't, okay? What we want is a charge to be established to here, and then the right-hand rule to push it this way, or whichever way it goes, very fastly, okay? And this charge will then spin like a tire spins, okay? The tire is actually spinning when it's spinning. All the spokes and the radial out on the tire are spinning at a certain RPM, a velocity, based upon that little circle. And the faster it goes, the RPM, the faster that it's moving, which is what we want. But there's another way to think of this, what could be going on, okay? Let's say there's a column of air here, beep, boop, and there's a column of air here, beep, boop, and there's a column of air here, beep, boop, beep, bop, beep, bop, and they're all segmented in columns of air. And then what could be happening is this is charging up one of these columns of air. And then the right-hand rule pushes the charge, and the charge goes over here and then excites another column of air, and this column of air is no longer excited. And it just keeps pushing the charge along, which is exciting the plasma. We don't want this, because then what's moving is the electric charge. And the actual plasma that's positively charged that we want to move would be static and just be lighting up. Lit, 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 lit. Nothing's really moving. It's an illusion. It's like having a row of LED strips, and they light up beep, 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 beep in a series that makes it look like they're pushing light that way, but it's all an illusion from just blink, 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 like that, really fast. If that's what's going on, then this technique is no good to us, okay? It will not generate any sort of moving positive charge like we want. But I don't believe that's what's going on, okay? Because if we look here, if it were to be the charge is moving, and it's just simply ionizing different particles as it goes, then you'd expect it to be a straight line making the connection. But if it's actually dragging at least some, maybe not all, but at least some of the plasma around and that charge, then there would expect to be a lag, from momentum and inertia kicking in, because it does have weight and is being affected by gravity, okay? Or other forces, electrical force, whatever. It's causing some sort of inertia to take place. And if that's the case, then it would be dragged, which is what we get in here. This signal here indicates that you have something, actual charges, that is being dragged along, and not just a force itself. Okay? So, I believe, and you see this is very slowed down. It's going very fast. Okay? Wow, it's actually making loops of itself too, trying to find stasis, and that's crazy. I didn't even know that. Look at that, I just did it again. Another loop, another loop. Wow, that's wild. Look at those loops. You see that loop? Man, that's crazy. I've never seen that before. I had no clue it did that. Which, now that I see this, could also be used to generate another form of a gravitational generator. I'm trying to move a charge, but you gotta remember, one of the ways that the sun blasts out its solar storms to us is it will have a loop of a gravitational thing, right? A flare, a loop that comes from the sun, and then it will twist and connect, and when it connects, it will sever the connection to the sun, and then it becomes its own connected thing, which now becomes forced out with all the forces of the electrical force of the sun and everything, and then everything blowing it out very fastly. I think they said like a solar storm, takes like 30 minutes to get from here to the sun or something, you know, it's only like 8 minutes going at the speed of light, so they're going pretty fast, like very fast. Fast enough that it might be creating, that we could use it to create a gravnetic field. So that's good that I'm seeing this, because that's another pathway we have access to now, availability, that could possibly generate a gravnetic field. But what you gotta remember is this is traveling very slow, okay? I mean, it's very fast by our standards, but by atomic standards and electricity, it's very, very slow. Now, if we have a electromagnet, say it's electromagnet, right? It's got electricity going through here. The electricity going through these coils would be going at virtually almost the speed of light. Okay, so it has a negative charge that's going almost the speed of light around whatever you want it to go. And so that speed that is going to generate a very powerful magnetic field, okay? So if we ever want to generate a powerful gravnetic field, then we're going to have to speed this up to close the speed of light somehow, which is going to be very hard if it's actual particles and not a charge that we're manipulating, okay? But it's possible. We can get protons and electrons going to like 99.99% the speed of light in particle accelerators. This is possible. It just takes a whole lot of energy. But if you're going to generate a gravitational field that you would think would, you know, make a spaceship fly, you're probably already thinking about the realm of those type of energies. Okay, you're probably not trying to do it off a gallon of gasoline. Let's be honest. All right. Another thing you have to know about what's going on here is that this gravnetic field theoretically should work whether it's in a vacuum or at sea level air pressure, okay? But the plasma that's generated does not work in a vacuum, because you have to have some gas to ionize. Otherwise, you're not going to get any plasma. And if you're in a perfect vacuum, you don't have anything in there. There's nothing to ionize. You can't make your plasma, much less make it swirl around. But you don't have to have it in the vacuum to make it. What I'm saying. But if you want to prove that you're doing that, and it's not just air pressure from ionic wind, you got to throw it in a vacuum, which is what I've done. So, but there's a thing we have to understand here.
And it's
all right?
not spinning because I have that stuff on it. Now
so here's a Tesla coil.
Let's turn a Tesla coil in a vacuum.
He's putting it in a vacuum, and he's measuring how much plasma it's going to create. Okay, and as you can see, the more he takes the pressure out,
got bigger and bigger and bigger.
When he starts taking the pressure out, the plasma will get bigger and more defined and more fluffy looking because it has less pressure and it can grow and it can transfer energy easier, okay? But there comes a point where, like I said, when you have so much of a vacuum that you have so much of the gas extracted from your experiment that you're trying to generate plasma on, that nothing is going to happen, okay? So he's taking the air out, and you can see that it's growing. But when you get to the point of a vacuum, this disappears altogether. So there is a sweet spot of what I'm trying to say of a vacuum. If you're trying to generate plasma in a vacuum, there is a sweet spot to do it. And I believe most plasma tubes are evacuated to roughly about 1/10 of an atmospheric pressure. Okay, so they got about 10% of the air in there that you would have at normal atmospheric pressure at sea level. All right. My experiment, I went down as far as I could. My apparatus goes down to minus 30 bar, so 1/30th, I'm pretty sure, of air pressure, which is pretty good vacuum. And at that maximum that I was able to do, I was not able to generate hardly any plasma. But if I pulled it back to 1/25th, I was able to still generate just enough plasma to conduct the experiment to what I believe was good. But there's only 1/25th of the air pressure in there. So that's going to severely cut down any ionic winds that are going to be generated from this device as it's going from this device, all right? Because what you got is it's going to ionize the wind, the air around there. And then the air, now that it's ionized, is going to travel from the positive to the negative, depending on what the ionized is. And then that's going to create air pressure, wind, ionized wind. Ionic wind is what it's called, okay? It's like when you have the lifters, the triangle things, that's what they're, the ionizing wind and pushing the air down very quickly to give it thrust. It's ionic wind. So that's what's going on here, and that's what we're trying to mitigate and to minimize in our experiment, is we're trying to take away all the ionic wind so we're left with just purely any force that would be either electrical or it would have to be gravitational, pretty much link to left, right? Electrical or moving electric charge, magnetic, or gravity or moving gravity charge, gravnetic. That's the deal. All right. So I guess let's go ahead and take a gander at some of these things here. Okay. Here we go. Okay. Let's try and make this a little bigger. Not too big, but a little bigger. Okay. All right. So here's my apparatus. This is a string of some sort, some thread that I was able to find, utilize at some DI store that didn't really have a whole lot of electrical charge to it when I put it next to my Tesla coil, seeing how much it was going to be affected. So I thought it'd be a good test because if it moves and it's not really affected by electric charge, and I can take all the air out to 1/25th bar and to minimize the ionic wind, and it's still moving, that's really good proof that there's some other force going on that we don't know about. Okay? And what we got is here is just another plasma bowl of, I think, of the simplest form of hydrogen I could find to be the most positive. I'm just throwing things in there to see if they affect anything. This is just really just for fun right here. Here's obviously the Tesla spin thing generating, the plasma in motion, and here's the string, and we can see there's not really a whole lot of movement going on here with this string. Okay, it is moving a little bit, but we also got these, radical spikes of plasma charges being released, hitting it too, that would move it, if it were to touch it. So this looks pretty bad, right? Of what we want. We're hoping that we're going to get something, and it's moving, but it's not moving a whole lot. All right. You see, there's some equipment I got. There we go. Here is like 1 atmosphere pressure right here. Okay. Here's like 25 bar, and here's like 30, minus 30 bar. So right now we're at like 26, 27 bar, right? 26 bar about minus. And we are still getting good plasma, being generated. If I go down all the way to 30 bar, it starts to go away pretty quickly. It's pretty bad, all right? Just showing you a quick setup of what I got going on, all the equipment I got. All right, so I got this bad boy in here generating this, and this created some problems, as we're about to find out. That's cool. I don't have to switch it again. That's really good. So here's the experiment I did again. This time, though, things went south. Okay. Light it up. I have everything. In case you can tell, I have high voltage being threaded into this from like right here. These are little strips of metal that I'm able to sneak in under the seal, where it still can make a seal, but it will allow me to feed high voltage in there. So I have multiple of these to feed multiple. I have like the Tesla, coil being powered by them. I have the arc generator being powered by it. So that's at least 2 things I got being threaded in there on different lines altogether. Because if I put it on the same line, it drew too much power and it wouldn't work for some reason. So I had to split it up. All right. So this went pretty bad. Okay, we got some movement. Okay, I guess that's some good stuff. We definitely have some movement going on, but it's not a whole lot. It's not enough, and for all we know, it's only moving when it's getting popped by the electric or the plasma spikes going between this plasma, vial and this plasma arc generator. Okay, with the Tesla coil lighting it up. Just bouncing between here, there, and all between everything. But something happened. Unfortunately, as you can see, it's starting to smoke up right here. This smoke's coming out, and now it's on fire. And yeah, I'm looking at it now, and I'm like, oh shit, it's on fire. And I'm like, what do I do? And I'm like, fuck. So I shut it off, and I let it air out, and then take it out. And this thing got totally melted, fried. Luckily, though, they gave me a spare, because they anticipated me being tarted like this. So, swapped out that bad boy, okay? And now we're going to more of the main test, all right? So, Here's the brand new thing I put on there. Now that I know, okay, don't put a Tesla coil next to it. Don't put, more plasma. It's just gonna arc to it and deposit all the heat there and melt it and burn it up. Excuse me. Drain damage. Getting blown up in the war. Whew. Art of killing and death. It takes a toll on you, even if you survive. Okay. So, here we go. Now, what I've decided here, because what I came to the conclusion of is that the string is going to miss a whole lot of gravnetic field energy emanating out towards it, okay? Because it's just a line. And it's just blasted, right? But it's all going around it because, pressure, it's how it works. So, I got the clever idea to make a disc of foam. Something extremely light, but was dense enough that if anything hit it, it should at least collect some of that energy, no matter where it got hit. And I cut it into not a cylinder, not a sphere, a disc. Okay, a disc. So it's this thin disc, right? But it's circular, and it's cut about the exact same size as this. And I try to put it as close to it as possible without it actually coming out, arcs hitting this and affecting it physically. Because if I put it any closer, that would happen. And I had to do this so many times because every time I would evacuate the air, the disc would shift. And so it would never be in the exact position that I want it to be. And I lucked out a few times and got it pretty close. I mean, it's got a little bit of a hook right here. Not perfect, but pretty close. And as we see this, when I hit it, you see it blast it forward. Like it blasted, right? It's moving it. Every time I hit it. Every time I hit it. There it goes, moving. Okay? So, that's pretty good movement. That's a lot of movement. Because you gotta remember, this right now is at least negative 25 bar. Okay? 1/25th bar pressure. So, there's not a whole lot of air in there right now. So, if it's moving, either there's a lot of ionic wind force, or there's something else going on, which is what I'm hoping is happening. So I did some research. I'm like, okay, how do I fucking figure this out? How do I decide whether this is ionic wind or a gravnetic field that I want to generate? Okay, and here's this. Okay, so right now we're at slightly just under 25 bar. It's like 24 bar, okay? I probably did that to get maximum plasma generated, but yeah, we're at just under 25 bar. There's 25 right there, okay? So we're like 24 bar, 1/24th of a bar pressure. Okay? So it looks like at maximum, it only goes over the width of itself, which isn't very much, okay? Probably like a centimeter. But you do have to remember it is tethered to a point above this. So it's going to take a fair amount of force to push it back, like swing it back a little bit, okay? It's not like if I just had it propped up, standing balanced, and I could, push it over. Okay, that's probably not a bad idea. I might actually try that in the future now that I think about it. But so what I'm trying to say here is this is going to be hard to determine exactly how much motion or force is being put into this right now, but that's what we have to try and determine. Okay, how much force is being put on this, whether it be from ionic winds, a gravnetic field, or an electric field. Let's pretend that this foam is electrically charged. It can be electrically charged. I put it next to a Tesla coil to test it, and it did not move at all. So I don't think it's going to be too susceptible to an electric field pushing out on it, but it's definitely going to be affected a little bit. Okay, so now we've seen it at negative 25 bar, negative 24 bar. So now I'm slowly trying to bring the air pressure back to normal, okay, back to 1 bar. That way we can test it at 1 bar to see how much it moves now, okay? So see, I've already got it. It's already going a lot now. Okay, I left it here. It looks like, which is, what is that? Is that 10 bar? Okay, 30, 25. So that would be, what is that, like around 10. So that's going to be probably around 12. So it looks like almost exactly half, okay? Half of 24, 12, right? Let's see what it does now. Wish I would have done that test a few more times, but we can see once again, it only goes over about the same amount, about the width of itself. It looks to me like it is a little more. It is definitely slightly more, but it's not as much as you think. So we got this. Versus this. You can tell it half the bar, it definitely is moving more. Okay, the question is how much more. That's what we're trying to find. Okay, so now we are at half bar pressure again. Looks like this is more from that same test. Okay, that's good. So I did test more. Okay, good. It is definitely moving a lot more. Like, there's no doubt about it. The question we want to find out is how much more. have to try and measure this. Okay, now I'm probably going all the way down to 0, to atmospheric pressure. Okay. And now let's see how much more does it move. It is a lot more. It is definitely moving more now than it was at 12. Okay, so that's what we need to find out. Before we can continue, we have to first determine how much is it moving at 12 bar. Let's say the most it moves is 1 width over. Maybe even 2 widths. Yeah, 2 widths over. Let's say that's about the most it moves is 2 widths over. So we're at 2 widths. We're at 2 widths when it comes to 12 bar. What about yeah, at most it's only going to go over like 1 width. We'll say 1 width. This is not looking good, boys. I'm not going to lie. It's not looking good. I was hoping it'd be a little better odds, but what it looks like I'm seeing is this is moving 1 width over of this foam disc, right? At minus 25 bar. And then at 12 bar, it's looking like it's going over about 2 widths. Okay? And then if we take it all away, yeah, maximum. And if we take it all away, how much does it move? At least 3, possibly 4. Okay. So it looks like it's standard. Okay. I'll show you what I'm talking about here. It's looking to me like what we've got is a linear relationship. Bloop. Where at 0 bar, it moves 4 widths. Okay. At 12 bar minus, it moves 2 widths. And at 15 bar, it moves like 1 width. This is the exact opposite result I wanted to find, I'm not going to lie. Because what this is insinuating is that there is a linear relationship between the air pressure and how much it's moving, which basically is alluding to the fact that it's probably mostly all ionic winds. So, what I wanted to do was to go over this equation. Alright? Free fall resistance air calculator, okay? Now what we can do with this is we can calculate shit like this. K K is the coefficient, air resistance coefficient. So if you have something like you're free falling, like a skydiver, your K determines how fast you fall, how much you're affected by the air resistance, okay? And the formula for that is density of air, which we know, and then the area of the cross-sectional of our object, which in this case would be a disk, a small foam disk, which would be, let me show you this real quick. Okay. So, oh, that's the wrong one. Okay, there. So, we can clearly see, I measured the width of this. It's not a perfect circle, but not the best cutter. It's about, what is this? Be, let's say, 4, 3, 2, so that'll be 1, 2. So about 2.5 centimeters, just over 2 centimeters in diameter, okay, is what this is. All right. And if we go to this one and look at the width, we can see the width is very, very small, probably like 2 millimeters. Yeah, 2 millimeters in diameter. 1 to 2 millimeters. So we know the dimensions of this. So we can determine this equation. But I'm lazy as fuck, and I know how physics work. And what I know is that in this experiment, this 2 is not going to change. The dimensions of coefficient air, a dimensionless coefficient drag is not going to change. And we use the same thing, so the cross-sectional area is not going to change, okay? And if we look at this, that the cross-sectional area of a disk is just A times pi r squared. Simple math. Look at this. This goes into the air pressure. Air pressure of air. And it tells us basically, here's the equation it uses to determine the density, and it's just, pressure divided by this, and this stuff is all the same. So the only thing that's changing is this top thing, the pressure, which we're taking with a vacuum. So this is linear. This is a linear change, okay? And then we come here, the density of air is breathable air. Our air is 1.29 kilograms per meter cubed. And then we also have the drag coefficient of a circular disc. It is perpendicular to what you want. 1 to 1.2 to 1.2.8. And here is some more examples of that. There we go. Bam. Here's our disc right here. Just acting as a barrier against air pressure. Very high. 1.2. Probably the highest of everything here. If you look at it, it's kind of weird. Everything else is lower. So we know all this stuff, right? And we can measure 1 bar, all this stuff. But none of this matters. It's all bullshit. It's all just filler and fluff. Because we kept everything else in the experiment the same except the air pressure. So we can completely neglect this entire thing and for just this one thing, okay? So if we go here and we times to do the math, what we're going to get is like it's K times, force, the velocity we're trying to measure what the force is. The velocity we know from movement. This is a linear thing, okay? So what I'm trying to tell you is that we did 3 experiments. We did one where the air pressure was 1. One where the air pressure was 1 divided by 12, and one where the air pressure was 1 divided by 24. Okay? So that is all we need to times this by. So 1 divided by 24, would that be like 0.04 roughly? So we would times it by 0.04, and that would get how much of air movement we would expect to see, okay? Which is linear. That's what we're talking about. We're talking about timesing 1 or 1 times 12 or 1 times 24, okay? 25, 24, okay? So, we have a linear equation, and we have a linear amount. The distance between here and here is equal and proportionate to the distance between here and here, is ultimately what we want to know. So, what we're trying to say is, I haven't crunched the numbers, but I've already seen enough of the math to know where the direction it's heading. It's saying that if it were to be generated from ionic winds or air pressure somehow, then it should be a linear, which is what we measured in our experiment, give or take. So, this is horrible news. What does this mean? This means that I have failed. I have failed to prove that I can generate any amount of a gravnetic field in an experiment using this device. This device. Where is it at? Where is it? What did I do? There we go, right here. Okay? But, as I explained to you, the caveat, when you're comparing this to, say, the output of an electric magnet, remember, the negative charge, the electrons, are traveling at near the speed of light as they travel around that magnet. That's what's generating the field, the magnetic field, okay? This is definitely not traveling anywhere near the speed of light. Where it's like 200 RPMs a second. I mean, if we take the circumference of this and then, do a little math, we can figure it out. It probably wouldn't be but, maybe like 200 miles per hour. Let's say 300 miles per hour versus the speed of light, which is like 300,000 kilometers a second. Not even the same ballpark. Totally wrong. So, I don't want to say we've learned nothing. What we've learned is that we cannot generate a gravnetic field going this slow. We have to find a way to speed the plasma up going in a circle if we want to see the effects of a gravnetic field. It's just the way it has to be. I wish I could do a much more precise measurement of these forces because, let's say that we are generating a gravnetic field, but it's only 1% of the force we're measuring from ionic winds. Totally possible. In fact, I would even say plausible. That's a plausible scenario based upon how I understand dynamic gravity to work. Completely plausible. But I'm unable to measure a 1% difference with this experiment. It's just not going to happen. There's just no way. It's not that precise. This would take clever experimentalists to design this thing where you can measure that and then have grade A, lab equipment to do that. So that's the deal. I was straight up, I did not lie to you guys. I did not know where this was going to go. I honestly thought I was going to see at least a smidgen of a gravnetic field coming out with the results, but based on what I see right now, I really can't even say that much. I do believe there is like 1 or 2% of this force that is a gravnetic field. I do believe that in my heart. I really do, but I cannot prove that. Not with this, what I've done so far. I can't prove it. So, excuse me. I said it's my last experiment, and maybe it will be, because if you know me and my channel, you know that I believe that Putin is going to nuke every NATO country, sending the world into a 5-month-long nuclear winter, killing 2/3 of the planet in about 9 months from now, give or take. And I just don't see myself being able to contrive another experiment that will measure to the degree that I want it to. But with the pushover method, who knows? Maybe it's possible. I might play around with it. Knowing me, I'll probably get fucked up one night. And whenever I get fucked up on drugs, that's what I do. I do science because I'm a weirdo. That's what we do. We're weird. I'm a mega male. That's what we do. We're fucking weird like that. We do all the bad things, and then we do all the good things with the bad shit. We're weird. But I'm not going to promise that. I'm only going to say that if, God wants to send me a vision of how to do this experiment where I can get the results that I can measure. I'm all in. Otherwise, I don't know. Time's running out, and I don't think I got enough left. Never have enough time in this world. Never. But anyways, another disappointing, depressing day here in the world of dynamic gravity. It must be a Monday, or a day that ends with a Y. That's the way it always works. But at the end of the day, don't let this discourage you, because dynamic gravity is still the only theory of gravity whose math works. And I mean it perfectly works in accordance with all observations. I literally got in a fight with some dude on a forum. I'm like, you find me one fucking thing that my math doesn't, say is okay. And he went and he found all the craziest binary star systems he could, and every single one of them fit perfectly with my math, but broke Einstein's math. Get fucked. So it is what it is. But, my dream of being able to create my own spaceship to fly to Zeta Reticuli looks like it has hit its final nail in the coffin, where I have been unable to generate even the slightest proof of a gravnetic field, despite my best intentions over 4 years of this. Say la vie. Adios, muchachos. Until next week. Bloop.
Like, subscribe, submit.